Hello, today is linear inequalities, and you will need a highlighter for today's lesson, so put me on pause if you need to go get that right now and get it from wherever you need it. The formula that we're going to be using today is slope-intercept form, so remember that is y mx plus b, and with inequalities we're going to use inequality signs instead of what's it called? Equal sign. So that's the difference between the slope-intercept form with equalities. It's equations, we're using inequality signs. So, vocabulary. In a linear inequality describes a region of the coordinate plane that has a boundary line. Now, when we had a linear line, that all the points on that line, worked. But this time, the line might not work, but the parts on the bottom or on the top might work, or the line might work and the bottom or the top could work. And we'll discuss it. We're going to use highlighters to help you figure out if it goes on the bottom or the top. The solutions of an inequality are the coordinates of the points that make the inequality true. So we're going to determine whether the point P is a solution of the linear inequality. So they gave you some points, a point, and we're going to plug them in. We're going to substitute to see if it works. So I'm going to, this is x and this is y, so I'm going to plug them into the x and the y section. So it's going to be 5 is less than 2 times 4 plus 3. So 5 is less than 8 plus 3. 5 is less than 8, 9, 10, 11. Is that a true statement? Yes, it is. So yes, that's all you're doing. Let's try this one. This is x and y. So I'm going to put negative 9 is greater than or equal to 3 times negative 2 minus 1. Negative 9 is greater than or equal to negative 6 minus 1. Negative 9 is greater than or equal to negative 7. Well, no. Negative 9 is a smaller number than negative 7, so it's no. All right. Now, graphing each linear inequality. It's the same ideas we've been graphing before. You need your B equals and your M equals. The only difference is this situation right here. So I'm going to look at B is that number right there. That would be 2. So I'm going to put a point at 2. And then I have M equals 3, and I have to make it a fraction, so over 1. So I'm going to go up 3 from the point. So 1, 2, 3 over 1. Now, if you have a less than or greater than sign, you're going to have a dashed line this time. Dashed line for the whole thing. So, I like a straight edge again, especially later on when we have to do 2 of these. Dash line. Okay, that's the first part of it. Now it says y is less than 3x plus 2 when you read the inequality. So less than means all the points under the line. So you're going to take your highlighter and you're going to highlight under the line. And I don't want just a little measly little bit amount on your highlighted on your graph. I would like the whole box that needs to be graphed. And that's how you would do your answer. B. This one's a little different. You have y is greater than or equal to negative x, but there's nothing else, plus, I'm guessing 0 because there's nothing there. So my b this time is 0, so I'm going to put a dot at 0, 0. And then my m equals, there's a negative 1 over 1. So that means I go down 1 over 1. Now, when I have a greater than or equal to sign or a less than or equal to sign, I have a solid line. So I'm going to have a solid line going around my whole thing. And I mean it's greater than the line. So that means it's all the line is greater than the line. So it's all of it. So there's your answer to this. Highlight it all. All right. All right, so here are the answers. I'm sorry I had to take a break from my recording, so I'm not sure where I stopped off at. So here are the answers for A and B. Notice the solid line for B starts at 0 and goes down 1 over 1. And the highlighted part is above it. Let's try the next example. Okay, write each linear inequality in slope-intercept form. So do you remember slope-intercept form is y equals mx plus b. That's the best way to, wrong pen, y equals mx plus b. That's the most helpful way to get your, to graph. So I'm going to bring x over to this side. To do that, I'm going to subtract x to both sides. So it's negative y is greater than negative x plus 10. And I'm going to divide by negative 1 to everything. So y, since I divide by negative, I'm going to switch the inequality. So now y is less than. I'm going to make that 1 over 1 x minus 10. So my b is negative 10 and my m is 1 over 1. So I'm going to graph it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, it's way down here at the bottom. And I go up 1 over 1. And it's a less than, so it's a dotted line. You don't really need to go too off the line on that. And it says less than, so it's underneath the line. So underneath it. And there you go. That's all you have to do. So let's try B. We need to get y by itself. Remember, you always, if the x is with the y, get rid of the x first by adding or subtracting it. So I'm going to subtract 9x first. So 3y is less than negative 9x plus 3. Divide by 3 to everything. So y is less than. Notice I didn't divide by a negative, so I'm not going to change it. 3 goes into negative 9, negative 3 over 1 time plus 1. So b equals 1 and m equals negative 3 over 1. So you start at 1, go down 3, 1, 2, 3 over 1. And again, it's just a less than, so you're going to put your dot. I'd like you to have a straight line. Wow, that's just really awful. Sorry, Miss Carson can't get it too straight when they're dots like that. But I like it straighter. And it's less than, so it's going to go underneath it. Less than means always goes underneath it. All right, again, the x is attached to the y, so I need to bring it over. So I'm going to add 6x to both sides this time. So it's negative 4y is less than or equal to 6x plus 8. Notice I'm always putting the x first because y equals mx plus b. That's why you do that. Then I'm going to divide by negative 4 to everything. Notice I'm dividing by a negative. What happens to the inequality? It switches. Very good. So reduce 6 and 4. That would be negative. Notice I'm putting the negative up on top, so much easier to deal with. Negative 3 halves x minus 2. So it would be b equals negative 2 and m equals negative 3 halves. Starts at negative 2 and goes down 3, 1, 2, 3, and over 2, 1, 2. Notice it's a solid line. So I'm going to put my solid line. Sorry, trying. It's difficult. Straight edge for you. And it says greater than, so it's above it. All right, something you need to know. Let's see if they have any more on the next page. Yes, they do. We'll do this really quickly and then... Okay, suppose Demi's budget for a party allows her to spend no more than $12 on chips and salsa. The chips cost $2 per chip. $2 per chip plus $4 per salsa. Find 3 possible combinations that she can buy. Alright, so the most, if she only got chips, she can have 6 chips. That's the most she can have. And if she had salsa, the most she can have, only salsas, she can have 3 salsas. So the most she can have altogether is something in here. So give me 3 combinations in here. I can have 1 chip and 1 salsa, or 1 chip and 2 salsas. I can have 3 chips and 1 salsa. Here's 3 combinations right there. That's all they're asking for. 3 possible combinations. All right, so if it's y is greater than 4, you would graph it and you would put it like right here. Y is greater than 4. Oh, it should be dotted though. So let me make it black. Okay. And then it's greater than, it would go this way. If it was less than, it would go underneath. But what if it says x is less than or equal to negative 2? So you would graph it here in this area. And it says less than, it would come over here. So that's how you would graph lines like this. All right, talk to you later. Bye.